Okay, let's move on to question number 3. So question number 3 reads, how do you find the domain and range of the natural logarithm? So the natural logarithm is basically like our logarithmic function, and the notation for the natural logarithm is, so it's log of base e, but we write it as ln. Okay, so that's what the natural logarithm is, and it's basically the logarithmic function of base e of the natural number. So the characteristic of the natural logarithmic function, or the ln function, is going to be the same thing as the logarithmic function. Okay, so in previous lessons I described how to find a domain and range. So the domain is defined as um, all values that define a function f of x. Okay, so all values that are valid and that define f of x. So any values of x, or any values that make f of x undefined, are not part of the domain. Okay, and the range is all possible values of of x, of function f of x. Okay, so the range means that all the values of the domain that map to something else, that those values that are mapped towards are called the range. Okay, so there are many different ways to find a domain and range, and for one, you can use uh, I guess, logical reasoning to find a domain, and you can use graphing to find a domain. And in the same way, you can also use the inverse function to find the range, or you can graph it to find the range. There are multiple different ways of finding domain and range. In this case, I feel like the best way of finding the domain and range is to just graph the function itself. Okay, so the junior tutor helps us graph it here. So you see here that this is the behavior of a ln function, and it's similar to the logarithmic function. So we see here that for the domain, it means that it's all values that define f of x, right? So we see here that the domain for this is that all x values that are greater than 0 will define our function. And if you think about this mathematically, this makes sense, right? So we know that ln, I guess, of x is equal to y, right? So this is equivalent to saying e to the power of y equals to x. Okay, so these two functions are related to each other by the inverse, right? So ln function is the inverse of our power function, our exponential function, right? So we see here for our exponential function that no matter what the exponent is, positive or negative, our value of x will always be a positive number. And this is because of the nature of the exponential function. You see here that the base is always going to be positive, and the exponent does not influence the sign of a result, right? So if we were to look at our inverse, that means that that the exponent could be positive or negative here, but our argument will always have to be positive. Okay, and if you guys want, you guys can graph your natural logarithmic function to see that this is the case. And let's graph that now, right? So this is our ln function. Okay, so if we were to add a different function here, and we would do y equals e to the power of x, this is what we get. So you see here that the range of this function is always positive, right? So we see here that no matter what, no matter if we have a negative exponent or a positive exponent, our argument, or our result, is always going to be positive. So in this way, if we flip it to the inverse, we see here that the domain always has to be positive. The argument of a logarithmic function can never be negative. Okay, so we now found our domain. So if I were to go back to our question here, our domain is x such that x belongs to all real numbers and x has to be greater than 0. So that is our domain. Okay, what's our range? So if we were to look at our function again, we see here that our range extends from all the positive numbers to all the negative numbers. So our range is y such that y belongs to all real numbers. Okay, so that's how you visually look at it. All right, you guys can use mathematical logic and your knowledge of functions to try to find a domain. And the last thing is that you can also try to use the inverse function to reason what the domain and range of your original function is. Because the range of your inverse function is going to be the domain of your original function, and the domain of your inverse function is going to be the range of your original function. So if you were to see here as an example, if we're taking into account the range. So the range, the domain of our inverse function, which is our exponential function, is x such that x belongs to all real numbers, right? So we see here that this function continues on and on and on and on, right? It just goes towards infinity, but we reason that all values of x on the real number line are valid and define our function, our inverse function, right? So in that case, the domain of our inverse function is equal to the range of our original function. So in that reasoning, we believe that the range of our logarithmic function is all real numbers, okay? So other than that, the solution is correct and we can move on.